Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we're working in Unit 3, looking at lessons 4 and 5, which are about linear equations in one variable. And to start with, just a little vocabulary. One of the things we're going to talk about in this lesson is the concept of a rate of change. And so we have a definition there. It says a rate that describes how one quantity changes in relation to another quantity. When we talk about a rate of change, we really are looking at how something is changing, and it could be over time or just depending on what we're looking at. So some examples of rates of change, you might have miles per hour. If you think about your car, the speed, that miles per hour, that is a rate of change. If we might hear feet per second, that's a rate of change. So there are all kinds of different things where we're comparing the changes of two quantities. And so we're going to be, in this particular lesson, we're looking at how can we write linear equations with a rate of change. And we're going to be using this kind of general framework for setting up these equations. So we're going to be taking the rate times the variable. We'll add any initial quantity, initial or starting quantity, where we started, and putting that all together, that's going to get us to a specific quantity. So let's look at that in practice here with this first example. It says, write an algebraic expression that represents the following word problem. If rain is falling at a rate of 0.6 inches per hour, so this is our rate of change, 0.6 inches per hour, and 1.3 inches of rain have already accumulated. So that's going to be our initial quantity. That's what we started with. They want to know how many hours must have passed if we now have 3.5 inches of rain. So that's the specific quantity that we're trying to get to. And I think Jojo is done barking now, so I'll try to get back to where we were. So those are our three pieces here. So our rate, again, was 0.6. The variable, we're trying to figure out how many hours. So I'm going to use h to represent that. So it's 0.6 times h plus our initial quantity. And we said the initial quantity here was the 1.3 inches of rain. That's what we started with. And that's going to equal our specific quantity that we're looking for. We want to know how many hours does it take to get to 3.5 inches of rain. So this would be our equation. And now, using what we did in the last lesson, we can then work on solving this. So we said we want to isolate that variable. We want to get that h by itself. I'm going to use a different color pen here just to make that a little more visible here. So we want to undo that addition. So we're going to subtract the 1.3 from each side of the equation. I don't have a lot of room to work here, but that's going to leave me with that 0.6h. And on this side, 3.5 minus 1.3 would be 2.2. I'm going to bring this back up here now and go back to using black. So I have 0.6h is equal to 2.2. And so then to solve this for h, right now that h is being multiplied by the 0.6. So I would want to divide by 0.6. And so if we do that division, we have the 2.2 divided by 0.6, and we would see that it's going to be, and I'm just going to round it off here, about 3.67 hours. So about 3 2/3 hours, that would be 3 hours and 40 minutes is how much time would pass for us to get 3.5 inches of rain. All right, let's look at one more example then. So in this one, it says we want to write an algebraic expression that represents the following. And then we're going to give the initial value. So it says An employee at the post office can sort 720 pieces of mail per hour. So it's pieces per hour, so that tells us that that's our rate. So pieces per hour. It says he's already sorted for 2 hours, so that's how long he was working. How much more time will it take for him to process 5,040 pieces of mail? All right, so in this one, we're trying to find that initial value um, and the algebraic expression. So for this one, we need to start by finding what that initial value is, because we know he's sorted for 2 hours already, and so we need to know how much mail that would represent. Well, if he sorts 720 pieces every hour, and he's done 2 hours, we're going to multiply it by 2. So that initial value, if you multiply the 720 times 2, you get 1,440. That's going to be the initial value. So that's how much mail he's already sorted. So when we go to do our equation, we have our rate times our variable. So 720. Our variable here, we're trying to find how much time it's going to take him to process 5,040 pieces. So time is our variable. I'm going to use t to represent that. Our initial quantity we found was 1,440. We're trying to find how much time it's going to take to get to 5,040. All right, so there's our initial value. Here's our equation. And if we were going to solve this for t, we would start with we need to subtract the 1440 so that we can isolate that variable. And we're doing that from each side. And so when we do that, we get 720t equals, and this would be 3,600 if my math is correct there. I believe I've got that right. Then to isolate that variable, right now that t is being multiplied by 720. We're going to undo that multiplication by dividing each side by 720. And so then our solution over here, if I take 3,600 divided by 720, I get 5. And so we're saying that it would take 5 hours for him to sort 5,040 pieces of mail. All right, that's all I've got for you today on linear equations in one variable. Appreciate you taking the time to watch, and as always, if you do have questions, please let me know. Thanks, have a great day.